Good evening, friends. Study with Apala, Parvin Singh book. Chapter 2, Earth, the tidal hypothesis. This figure A, star, S sun, F, B, sun, F means filaments. F sun, this tidal hypothesis of Jean's diagrammatic explanations after Boris Lewis. It had been the most popular hypothesis of the first half of the 20th century that attributed the origin of the solar system to a simple but mysterious process. Jeans and British astronomer postulated that the planets were formed from a gaseous filament that was turned out from the suns under the influence of another major stars that happened to pass through at certain times quite nearer to the parent suns. That why a filament of a gaseous mass was turns out from the parent sun is explained simply as due to gravitational pull of the passing stars. This gaseous filament is supposed to have been dragged by the passing stars for some distance in the space. Ultimately, when the pull decreased, the filament was left behind, revolving around the sun and gradually breaking down into planet like stars, the parts that kept rotating around the parent suns. The tidal hypothesis explain to some extent the distribution of angular momentums conditions, but fails in many other important respect. Thus, for instance, the very possibles of encounters of any true star in space in a manner postulated in the tidal hypothesis is considered very rare. The stars are so far apart from each other in a space that passing of one star near Earth to another and exerting and dragging influence is amongst highly improbable, if not altogether impossible events, that the vast disseminations of the solar system that ultimately developed from such a drag effect are not at all satisfactorily explained. If the passing stars were to succeed in tearing some matter out of the suns, it would have to pass through the immediate vicinities of the sun. In such a case, the turns filament and the planets subsequently develops from that should have been revolving closer to the sun. But as we know, distance that are thousands times greater than its diameter separate some of the planets from the sun. Thus, this hypothesis actually fails in explaining completely given the conditions of angular momentums. Under the postulated conditions of tidal attractions, materials at exceedingly high temperatures, about 1 million degree, would have gassed out from the interiors of the primary sun. Such a type of gaseous materials would have easily dispersed in the space rather than remains around the sun to form a planetary agglomeration. Thank you. Like and support this channel.